In this video, we're going to look at an example of a randomized block design ANOVA hypothesis test. So let's look at a study that measures fatigue and stress of air traffic controllers. This study involved modification of their workstation, and three specific alternatives for the workstation redesign is under consideration. And the objective of the study is to see whether there are any differences in the three designs in terms of the fatigue and stress experienced by the controllers. And is there one design that results in the least fatigue and stress for the controllers? The three workstation alternatives were installed in Cleveland Control Center, and 6 controllers were selected at random. And these 6 controllers went through their work day in each of the 3 workstation designs. And after the experience, and there was a follow-up interview and a medical examination that measured the fatigue and stress level. Now, the important thing to note here is that each controller is assigned to each of the 3 designs in a random fashion. So one controller may go A first, then the B design second, and C as the third one. And another controller may go like B first, and then A, and then C. So the order in which they work 3 designs is randomly determined. So here, the factor under consideration is workstation design. The treatments are the 3 designs. Okay, system A, system B, and system C. The block factor here is the 6 controllers. Okay, there are differences among the 6 controllers, the way they will feel the fatigue and stress. That difference is not of interest to us. We are interested in only studying the stress and fatigue caused by the different workstation systems. And that's why that is the factor, and the controllers, okay, they are the block. The response variable is the fatigue and stress score measured after they have used one of these systems. The experimental unit, okay, the controllers, and the type of study is randomized block. Now let's look at some notations. Okay, so we have 3 populations, one for each workstation system redesign, A, B, and C. And population 1 is the fatigue and stress score for system A. Population 2 is for system B. Population 3 is for system C. Then we define mu sub 1, mu sub 2, and mu sub 3 as the 3 mean fatigue and stress scores for the 3 systems. We have 3 variances, sigma sub 1 squared, sigma sub 2 squared, and sigma sub 3 squared for the test scores for the 3 system designs. Of course, we'll have to assume that these 3 variances are equal. We'll come to that in just a second. The hypothesis that we want to test is whether these 3 means are equal or not. And in order to conduct that test, we have to make some assumptions. And that is the response variable. In this case, it is the fatigue and stress scores, follows normal distribution for each of the 3 workstation design. And the 3 variances are equal, so we have a common variance. And the samples taken from these 3 workstation designs are independent. Now at this point, we'll turn to Excel and look at the sample taken from this study and we will conduct the hypothesis test using data analysis in Excel.